Hello everyone, this is Nitin from SIMCom Wireless, Field Application Engineer based in India. Today I am going to demonstrate you about SIMCom A7672 series of modules, Open SDK development. What, uh, what deliverables SIMCom provides you and how you can make use of it to develop your first application. We will see all those things together. Right then. So in front of you, so you can see that there is an SDK which SIMCom provides. This SDK directory covers multiple subdirectories. So for a beginner, this doc folder will help you with some ready-made references. Like you will have some API programming user guide, debug user guides as well, plus some hardware related documents, which will help you to map GPIOs, interrupts, SPI, I2C, all those details. So you can refer more details on this hardware documents as well for this. And this SDK folder will have multiple subfolders inside it. Okay, so I'll take you and explain you each one of this folder for your better understanding. These directories are structured in this way, and each directory has its own sub files. Okay, that are required to build the project. Okay, so let's understand each one of them one by one. SC underscore app. This directory basically is the user application directory. Under this directory, users can create their projects and write their application. For example, under this SIMCom demo directory, there are some ready-made references created. This ready-made project has been created as a reference for the user. Okay, so we have created this project under the SIMCom demo. Along with that, SIMCom application directory is there, which also has a .c file. Basically, SIMCom application.c will help you to create an entry point of your project, and the entry point function will call other functions. We will see all these things more in detail later. Under scconfig, there are some script files and a boot is there. So basically, users don't have to deal with this directory because these directories are this directory has a script files, and those script files basically required are essentials to build the project. So these scripts file will help compiler to build your applications basically. So these are already created and uh, saved inside this directory. You don't have to edit this thing basically. This is the only folder as underscore app where user mostly dealing with. SDK images. Under this folder, we have some system images and RF files. If belongs to all these variants of A767 modules. The SIMCom ASR based modules has multiple variants, and each variant has got some their own memory variants. We have 16M and we have 8M memory variant, 8 megabytes and 16 megabyte memory variant. So if you are creating a project, you need to know which module you are intent to work on. So based on that, you have to select that particular module image, and that will get patched with your application image that will be created. We will see more on this while during the compilation stage. SC underscore tool Under this directory, you will find some compilers related, compiler related, cross compiler related directories. That is cross compilation tool, GNU make, and a boot tool for flashing, and Python setup, and zip tool. So again, user don't have to edit this part as well. These tools are readily available to cross compile your applications and this will help you to build the image, and that final image is basically required to flash it into the SIMCom module. This is called a target directory. The target directory will be created whenever you create an image. Whenever there is a target image created, this will be created under this target directory, like this. Whenever the target image created, it will just look like this. Okay, it's in a form of zip file, and this target image actually is a combination of the 4 SDK images and your application patch. So basically, this target image has been created in combination with this SDK images of one of your module variant, and your application patch. So these two get merged together and we create this target image. So this target image is the one file which you can flash it into the module. Of course, there is another way where you can just extract this zip file, and under the zip file you can find this customer app bin. So this customer app bin is only your application bin file. So you can just flash your application bin file using our boot tool. Okay, so that is another way of doing it. But to make things simpler and smoother, one single zip file has been created. So we can use this zip file to flash it into the module. Okay, so these are the subdirectories under this SDK folder. Along with these subdirectories, you will find that some batch files are given. So these are batch files created for Windows. We have to use Windows PC for building this SDK. So our compiler supports Windows, and we have created a batch file. And under this batch files is basically is creating a setup where you will, whenever you send a command to compile the project, this batch file will call the make files and the path of all those directories, user directories, which are going to be part of your build process. Okay, this is basically your, yeah, command prompt console shortcut. We'll be using console to give the instruction to build the project. Okay, so here we go. So let's start building this one application. Okay, what I am going to do, under this sc underscore app, we have SIMCom demo and SIMCom application. So these two directories will be the part of my build process. Okay, so I'm going to build basically those two directories under this sc underscore app. How can I select which directory to build? So that I have to define in this makefile. Under this makefile, I can select this particular directories which I want to build it. Okay, let me just open this makefile to give you a clear picture. Under this makefile, you will find that I'm mentioning SIMCom application directory and SIMCom demo directory. Okay, for my build, along with that, I have also mentioned third library. Third library basically, you can add some third-party stacks as well. It can be SSL stack or a JSON stack. So in this third-party library, we have a kind of JSON.chain.h. These are third-party libraries that you can also use uh, as a patch to compile the project. Okay, now I'll I've just opened this makefile and I'm showing you SIMCom application and SIMCom demos and third library. So basically these three directories will be used for building and compilation. If later on you create your own directory or project directory, you have to edit this thing in this makefile. Okay, this makefile, it's here only. I mean this makefile you have to use. Okay, so let me run this console. I'm selecting a module A7672 FASC, which is a 16 megabyte of memory. If your module supports 8 megabytes, so you can select build underscore 8M. We have 8M and we have 16M only. And if your model only supports LT, then you can select this batch file. So if your model supports LTE plus 2G, then this batch file for 16M and this batch file for 8M. Okay, so I'll run this build underscore 69 batch file space. I'll give my module name. I'm selecting FASE because that's the model variant which I have. You can select your own variant based on that. But you have to make sure those variant details, variant information is already a part of SDK image, SIMCom SDK image. This variant should be visible here and all required kernel files and the RF files should be a part of this variant. I'm using this variant, so I have all these required files here. So the required patches from the kernel side and the RF files are here only. So this will going to be a part of my build process and along with my application. So I'm selecting A7672 underscore FASC and this app. App means when I'm going to build my application. First of all, I'll do clean because clean will help to clean up all my previous builds. Any object files or assembly files which has been created will be cleaned up before. So the clean has been done. Now I'm going to run this app. You can see the build process has been started. So basically what you are seeing here, all my .c or .h files which are a part of our projects, uh, this compiler is building that. This all .c files, this as well are being compiled. Under SIMCom library, I forgot to explain you about this folder. This SIMCom library contains API libraries and .h. Okay, so this API.h libraries are here. You don't have to edit this part. Okay, because these are pre-built API libraries available for the users. So basically you can see in this console, the build has been successful. I got this message success with my CRC value and I got this message compilation successfully. My build is successful now. With this, I have successfully built application, demo, and SIMCom library because library contains those API.h files as well. So basically, I have successfully built this tree directory. Okay, so this is my application build. Now I'm going to create uh, the target image. Before creating the target image, I want to show you this application library. After building this application library, under this build directory, you will find that my bin file, ELF files, and the object files will be created here. This will be refreshed here. Okay. Now I'm going to create my target image, the target image which I'm going to flash it into the module. So here instead of app, I'll use image. So as you can see, my target image has been generated successfully. Where I can get at, I'll go to this target folder. In this target directory, I'll find this image created successfully now. This image I will use to flash it into the module. Okay. Now to flash it into the module, we have a flash tool, something like this. I'll use this flash tool. I'll select that target image which I have created just now. Okay. Then I'll click on Flow. After I get this message, I'll connect my module to my PC through USB. Okay, for that pre-required USB driver should be installed. So once that is done, I'll flash this target image into the module. Okay, so I have a separate video for that, how to flash the target image into the module, that I can share it after this. So basically here we are focusing on the build process, how to build the target. So what we had just seen that we have successfully built an application, and we have created a target image and which is ready to flash it into the module. Okay, now one quick thing, if you want to create your own project folder, so your project folder will be an alternative of SIMCom demo. Sorry, I create a project folder. Under this project folder, I will create my .c files like this and make file. This make file again will have the declaration of all this .c files, which will be the part of my build process like this. So if I'm creating a project folder, I make sure there is a make file for it, which will have the declaration of .c files, which is .c and .h files, which is a part of that directory. Okay, and I have to edit this make file as well. Instead of SIMCom demo, I'll use project one, which I've just created. So with this approach, I'll be able to compile my project one instead of the SIMCom demo. SIMCom application will remain as it is because that is an entry point function. Okay, so I'm not going to touch that unless until I'm doing some compilation, but whatever the project I create or user create, SIMCom application will be common for that. That's because SIMCom application is the entry point function. So entry point function is required under SIMCom application. So that is always be there. And along with that, your project folder will be there. I hope this video is helpful for you to create your first project and to build your application and flash it into the module. Thank you for watching this. Best of luck.